This video is just a quick reminder of how the quotient rule works, and then we're also going to look at an interesting follow-up question where we work around the quotient rule by using the product rule and the chain rule. That's good practice, and then we'll make sure that our two answers are the same. So here's the statement of the quotient rule. I have a function f of x divided by a function g of x. When I differentiate that quotient, I have to take the derivative of the numerator, leave the denominator alone, and then subtract a term where I leave the numerator alone and differentiate the denominator, divide the whole thing by the square of the denominator. So let's apply that to this example. H prime of x is going to be the derivative of the top, that's just 2x, times the denominator left alone, that's x minus 1, minus the numerator left alone, derivative of the denominator, which is just 1, all divided by the denominator squared. So I'll clean things up a little bit. I'm distributing in the numerator, and I get 2x squared minus 2x minus x squared plus 3, all divided by x minus 1 quantity squared. I can combine my quadratic terms, and I get x squared minus 2x plus 3 over x minus 1 quantity squared. Okay, let's look at the workaround method. So I have h of x is x squared minus 3 over x minus 1. Well, what if I wanted to just view it as a product instead? So it's x squared minus 3 multiplied by x minus 1 to the negative 1 power. When I apply the product rule to this, I get the derivative of the first term, that's 2x, times the second term left alone, plus the first term left alone, multiplied by the derivative of the second term, and that's where the chain rule comes in. So I differentiate this piece with respect to its interior, x minus 1, treating that as a single variable, and that gives me negative 1, x minus 1 to the negative 2 when I apply the power rule. Then I have to tack on the derivative of the interior function, which thankfully in this case turns out to just be 1. The derivative of x minus 1 is 1, so I'll just be extra thorough and write that. I ultimately, in order to compare these answers, I want to express this with positive exponents as a rational function, so I'm going to start working on that in the next step. There's the first term rewritten, and then in my second term, I see that I have a negative 1 there in the middle, so I'm going to have a negative term, and it's x squared minus 3 divided by x minus 1 quantity squared, moving that into the denominator with a positive exponent. Then I need to get a common denominator, so I'm going to multiply the first term by x minus 1 over x minus 1. That's just a fancy way of multiplying by 1, but it forces the denominator to be the same as the second denominator. Then I can go ahead and subtract the numerators and write them over the common denominator. So I have 2x times x minus 1 minus the quantity x squared minus 3, all divided by x minus 1 squared. Distributing in the numerator, I get 2x squared minus 2x minus x squared plus 3, all divided by x minus 1 quantity squared. And finally, combining like terms, I have 2x squared minus x squared, so that's 1x squared, minus 2x plus 3 divided by x minus 1 quantity squared. And this matches our original answer, so we're good. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.